Next up is NATing, or just NAT. NAT stands for Network Address Translation. Now, basically the sole purpose we have NAT is because of private subnets. Okay, and the thing I just told you in the routing, where if you send a packet somewhere else, that guy must be able to reply back. But what if this subnet is a private subnet? Okay, usually the red indicates private subnets. Well, it's only here actually. But these red ones are subnets, are private subnets whenever we get there. So this is a private subnet. That means the device in there will have an IP in these ranges, because it's a private IP, private subnet. But now, it reaches a server on the internet. So obviously, if you look at the packet contains the source IP import as well as the destination IP import. Now the source IP is a private subnet. But now, obviously, where does it send it? Because 1 million people in the world might have that same subnet. So it doesn't know where to send it. So basically what happens is it drops the packet because there is no route to that subnet. So that's why NATing was invented. So basically, network address translation. It translates your IP to another IP that is public. And that sits between two networks. I've drawn a sketch here, where you have your private subnet and your public subnet. I've just basically created a half a circle because that's very big. Okay, and here's your private one, where each dot here obviously signifies a PC or a device or a tablet or a printer or whatever. So if a PC wants to make a connection to the outside world, as soon as it reaches the NAT disguises itself as a gateway. So to your PC, that looks like a gateway, but it's actually not a gateway. It's a NATed gateway. So as soon as it gets there, the connection officially stops. Effectively, that connection stops. The NAT then makes a new connection out to the actual IP. But the NAT, as a gateway, it's got two IP addresses. One IP address sits in your private subnet, and the other IP address sits in your public subnet. So basically, that in this case would be your NAT. So now, if you send a packet there, your packet source would be your public IP on your NATed router. The typical example of a NATed router is an ADSL router. So the ADSL router we have in the office is a NAT gateway. It actually has two IPs. It's got a public IP, or they call it a WAN IP, for wide area network, and it's got a private IP, which is our LAN IP. So it basically translates that. So it basically has two connections or two sockets. So that's why I say with normal routing, it's one connection, one socket, one route, straight through. Where here, it actually splits the route. So here's one, and there's one. It sort of fakes, there's a bit of a mask, or a person that don't show their true personality. They fake a bit. On the private subnet on this side, it actually disguises itself as a gateway. So your PC thinks it's a gateway, and it responds exactly like a gateway. Even if it was a gateway, it will almost like look exactly the same. There's no way of knowing. And on the other side, the public network, it actually disguises itself as the end device. So the public network will think that is actually the device it's talking to, although it's actually talking to that device. Because what the NATed router does, it stores a translation table for cross-referencing. It's got, each connection is an IP and a port, which is a socket, we'll get to that. And it stores these pairs, IP and port number. It's got an index table where it stores IP port, IP port. One's for this side, other one's for this side. So as soon as it receives a packet on this side, it goes and looks at this table, and it says, this is the associated connection on this side. And it just sends on the other side. You see, so it sits in the middle and actually like fakes requests, basically both sides. So it looks like you're actually speaking to someone, to do the actual thing, but you're not really, you're actually speaking to a middleman. So that's what the NATed router does. Obviously, one of the problems with a NATed router is we've got an IP address on the public side. The router does have an IP address. And now if somebody goes and he connects to that IP address, it's a new connection. It's not something that exists. The NAT root is not going to know what to do with that connection because it doesn't exist in this table, this translation table. Only if it's something on the private side and wants to connect to the public side, then it gets created and inserted into the table. If it comes the other direction, it's not going to know. That's only on new connections, not existing ones. So a connection can be created from this side, or we actually should call it, a socket. Whenever I refer to it as a socket, it's actually a connection. If a socket gets created on this side, it will actually work and insert in the table, it will be function fine. If somebody tries to create a socket from the public side, it won't work. Because how does the router, the destination of that packet is going to be the router. So it doesn't know where to send it to the subnet. But from this side, the destination IP won't be then the router here, it will be actually the destination. So the router knows, or the NAT router knows what to do with that packet. And that's where port forwarding comes in. We often hear the term port forwarding when you're trying to host games on your router. Basically what that means, you're going to have to tell this router to forward a specific port to an IP on the subnet. So the destination on the packet is still the NAT address, but it's going to be a specific port number. Let's say port 1111. You configure it there. If somebody tries to connect from this side to this thing's IP on 1111, then make a new connection to this specific PC. Then basically in essence what you're doing is you're exposing that PC to the internet, but only port 1111. Okay. You can also obviously set up port ranges. So you can say from port 1000 to port 2000. Route all of those ports to a specific PC, then you have a whole range. You can even forward all the ports if you want to. Then it means that if somebody connects to that, initializes a new socket to that one's public IP, it will always route the traffic to a specific PC. Although that can be a big security issue. Because the NAT gateway makes everything very safe. The PCs on this side, if they don't make outgoing sockets, then technically no one's speaking to no one. And you can't from the outside initiate a new socket in. You can't, it's not possible. You can only connect that way. So that makes it very safe. So if a hacker tries to get to one of these PCs, he can't. The NAT will just block him. It will just say, sorry, you can't, I don't know what you want to do. So it'll just drop the packet. So if you have a NAT gateway, you don't technically need a firewall. If you obviously know what you're doing on the internet, you don't click weird, funny download buttons that doesn't actually exist. Okay, thank you. So let me just see if I've covered everything. Yes, so obviously, if all of these PCs in the subnet connects to something on a public server, or connects anywhere in the public, wherever they connect, the source address, source IP port is going to be exactly the same IP. The port will be different, the remote port, but the source IP will be exactly the same. So if your PC and your PC connects to a site, that site will think it's the same PC because it's the same IP. Obviously that's where stuff like sessions comes in, cookies to track which is actually your PC and which is not. So they all basically share a public IP. And there's just where a lot of sites sometimes do it wrong, is where some sites, like let's say some video sites, or some software sites, or download sites, you can only download a certain amount of files, a certain amount of megabytes, or download or watch a certain couple of minutes of video. Then it blocks you. And will say, sorry, your quota for video watching for today is, you've reached your quota, you can only watch again tomorrow. Sometimes what they do is they block your public IP. So they use your public IP to track whether you've watched videos today. But now the problem is you're sitting inside an NAT network. So you're actually sharing the IP with 10 other people. So what happens is that somebody else watches something, and he actually reaches the quota. Now you want to watch thing and it says that you've already reached your quota, but you haven't watched anything. It's actually because of how the NATing is set up. Okay. If usually on a cell phone, your cell phone, your 3G connection is actually inside a private subnet that's behind a NAT router. So if you go to some of these sites, I can't actually remember any of these sites I used to have. I know there was a site that I had a problem with long ago, but if you go and look at the cell phone, this site will typically not work because you're actually sharing a public IP address with literally millions of other users. Whereas if you have ADSL, I'm not talking about all ADSLs, your major providers like your Telcoms, your MWebs, they usually will give you a public IP address. So if you connect, you'll have a public IP address. So your physical router the IP address it has there will be public. Some of your cheaper providers that offers you a lot of discounted rates, what they do is this side of your router is actually not public, it's still private. And they put everybody behind a NAT router. So I think Afrios used to work like that, but I think they've changed it. But a lot of these sort of fly-by-night internet service providers, they actually put a NAT router for all their users. And everybody uses the same IP to serve the web. The only problem is port numbers. Because your NAT router on this side, you have one IP, but the only available port numbers you have is 65,000, a little bit more than 65,000. So if you have, and it's not clients, that's connections. And a PC can open up hundreds of connections, one PC. So it becomes a bit of an issue if you share IPs between users. Obviously your cell phone providers have a whole list of NAT routers that they use. And they will find one with entry still available and they will send you on that one. So, but it is something to manage, obviously. And obviously a NAT router supports multiple protocols. So it supports UDP, TCP, ICMP. There's no limit to the protocols that you can have. Okay. I think that covers NATing. You guys understand NATing? You have any questions? Not yet? Cool. Okay.